the integral of the product of the cost function weighed by the probability. And that's what we can use as a robustness measure. And in this way, we can select a robust plan as opposed to the overall cheapest plan. The problem with that approach, though, is we will be conservative. In this case, we would probably prefer hash joins over nested loop joins most of the time, which may not be the right choice all of the time, as you know. So that means that alone cannot be the decision metric. So there has to be some other metric that we have to use. And what our feeling is, we want to start with a robust plan to avoid catastrophes. But at the same time, when there's an opportunity to improve that robust plan, we should actually exploit that. So when we run the query, or this complex operation, at some point of time, we'll have more information, we can check, isn't there maybe a chance for improving? And if we have information for improving, then we should improve. Now the question is, of course, which plan should we then select as an initial plan? Because the most robust plan may be a plan where we cannot really improve upon. Because it's very hard to actually, or the cost of adaptation is very high because we will have a switching cost. And what that means is we actually have to trade off the risk of regression and the opportunity for adaptation and select a plan in this space. So that would be one of the challenges, and that's one thing we're going to tackle. So there's a couple of related work. I already mentioned a lot of it, I think. So of course we have programming model Hadoop, MapReduce Merge, and programming by contract by Bertrand Meyer and Eiffel. Dried link is a very interesting piece of work to look at. And of course optimization, I think I can spare myself. You know more about that than I do, I'm sure, but gamma rays, DB2 optimization, so then just that, but also the other work. So this is just about stratosphere. We have an application of building a more richer data model on top of that. For our use cases in climate research, text mining, and data cleansing. So this is just to give you some intuition. And just before I conclude, I want to point out one more thing. That was also one of the reasons actually why I ended up going to Berlin after my time here in the US. There was some other place in Germany when I made the decision to go back to Germany. And that is, in Berlin, there's actually a critical mass of database research, which is something really to point out. So there's not only me there. So there's a group of professors. We have a couple of universities, as said, and there's Christoph Freitag, Oliver Günther, Ulf Leser, Felix Naumann, and Heinz Schweppe at TU Berlin, where I am, Humboldt University, Free University, and the Hasso-Plattner Institute. And we are actually really working very hard on leveraging this critical mass by having a joint colloquium where we bring in internationally renowned speakers and mixed researchers from the participating institution. Bernie actually has given a talk there once already. And we now with the Stratosphere project embarking on a joint research project to co-advise PhD students and collaborate in courses and lectures. So there's some close collaboration going on. So with that, just if you're ever in the Berlin area, we'd be happy to welcome you to come by and give a talk, interact with the students. Students have a lot to learn from all of your practical experiences, so they're extremely valuable. So I would be very, very happy to see some of you come by, give a talk and interact with the students. With that, thank you. If there's any questions, I'd be happy to answer them.
Maybe one. Thank you very much, Volker. Just one question from me. These stages, the user doesn't have to define where to put these plans, right?
Correct. No, that's all a decision by PAC compiler. So this is on the net level. So you just, as a user, you just define your contracts, and then they first. So basically, you are really programming in a model. So the way I drew it, it looked like data flow. But I think in the future it will look different. It will really look more like a functional program. So you really define a second order function with an associated first order function. And of course you combine many second and first order functions together. And then based on this functional program, the compiler will generate everything. Right? So it doesn't even have to be a graph that you draw. So you could draw a graph like when you use the data stage or so, which is similar to functional programming. Right? Yes?
So with the structure you have, are recursive queries represented?
Recursive queries, at the current stage, we have not looked at cycles in the DAGs yet, but nothing in practice actually prevents you from doing that, and also nothing in theory. The thing is, right now, we don't really do cycles yet, but that's something we will look into, yes. But there's no principal obstacle. you would need to define, the only thing is we would need to define pacts that enable you to express that on that level, right? We don't have any pacts that do that.
How much controls do the users have in terms of the association of the nodes, right, that the program is not to, like co-location?
Right now, none. So
None?
the user does not have any control, but of course it's a research prototype, right? So we have to be also very clear about that. So, and our goal is of course not to necessarily give that control out, because that's an optimization decision we would want to make. In the end, the co-location should be decided based on the pacts, right? So that's the whole idea of the parallelization contracts. They should enable us to know which things should be co-located. If you talk about data placement now, right? I mean, like that's something we have not looked at yet at all. We're just using HDFS for now. I foresee, however, that in the future, with some other PhD students in the next year or two, we may want to look actually also at that and making HDFS a little bit more aware of location. In this way, worry about data placement. And then, of course, the user would have to specify where the initial data is being placed and in which way.
I guess I was just to follow up, just trying to get your perception on, sometimes perhaps it's better for the user to specify things versus trying to let the system figure it out, right?
Optimize the profiles.
Pardon?
Yeah, giving hints, basically. I mean, for a commercial system, I totally agree, and you probably would want to provide those kinds of hints. For us as a research prototype, we really want to see how far we can push it without the user having to do that. But yes, I mean, that's always the end shortcut we could take. And we may very well, if we apply it, if the climate researchers really decide to use that system and it works, right, we probably would have to do something like that if it's really, if we really have a real user. Yes.
Is the communication blocking or not blocking, or is the user able to choose between those two?
Right now the communication is not blocking. So the blocking happens actually through the stages, right? So, but well, we have to talk about different levels here, right? So on this network level, that's communication channels, they're not blocking. But of course, the stages, a stage has to be completed to some extent before the next stage can start, even though we are currently thinking about it, that's not quite true either. Because you actually, we are trying to play some smart tricks, like sampling or getting data from one stage to already determine the degree of parallelism for the next stage, things like that, right? So you would actually even already read from the partial result in order to at least set up the next stage already. But the stage per se, in our current thinking, is more or less blocking, except some kind of those kind of parameters.